Hi, my name is Markus Eisele and I'm the Developer Adoption Program Lead for Red Hat EMEA. Today I'm going to talk about developer joy and why this is important. If you want to learn more about all kinds of technologies around Red Hat, Java, OpenShift and our middleware, please make sure to follow me on Twitter at myfear. Today we're going to talk about building software. We're going to talk about what it takes to build software, what changes were introduced over the last couple of years when we did the switch from centralized applications to monolithic applications in decentralized hardware, and when finally containers got introduced. We talk about the developer experience, how important developer experience is, what it actually is that makes developers successful and productive. We talk about what happened when containers got introduced, and we're talking a little bit about how we can bring back fun into this whole mix. And let's look at what the typical Java developer does during his day-to-day job. Usually everything starts with an idea. And this idea is laying the foundation for every supportive Java or software development project that is going to be created and help aiding this idea. We start with an IDE, which is an integrated development environment. You probably have heard about Eclipse or IntelliJ before. And you create source code. So you're putting ideas, business ideas, into a flow that can be read by computers. And the source code is put into a project repository, which you can consider like as a shared folder somewhere. It's usually hosted on some kind of source code control system. These days, it's very famous to host it on GitHub in a very public or even private manner. And when the source code fits your needs, you have to compile it, especially in the Java language. And the outcome of the compile is some kind of package. It's a jar file, which is another zip file. So, and the Java virtual machine can execute this package. So you can run your test cases against it. And you do this cycle like over and over again until every business requirement is met, all the test cases are green, and you take everything else that's important for your software and add this to like a bigger package that actually can be physically or technically via a wire distributed to our operations people. And these people, processes, whatever is behind operations, usually took this package and put it into some kind of an integration environment where the broader parts got tested a little bit more deeply. And it was staged after that into production. If we look at the software development lifecycle, how much time is spent in the individual phases, the bulk is spent in the coding phase. There's a little bit of time that is wasted literally on building some packages or the combination of your software pieces. There's a very productive testing time that is insanely necessary to make sure the quality requirements are met. And ultimately there's distribution phase, right? So that is kind of the normal distribution of the software development lifecycle that we've seen a couple of years ago. And this was good. This was very productive for an individual developer. And we still strive to be better than that. We strive to scale this to teams. We strive to make this more a factory pattern, to be a productive software delivery company. We needed to make sure that we met the complete and automate the complete supply chain all the way to the ultimate production. And I already said automation was the key to the next step that happened. So instead of having this initial cycle where everything was just about putting code from your IDE to the repository, build whatever is successful, tested, and distributed to somebody putting it into production ultimately, we integrated something that is called continuous integration, continuous delivery. So kind of think of it as an automatism that takes whatever source code is put into a central repository, takes it from there, builds it according to recipes, and checks if it's correct, and takes over the complete distribution. So getting all the required approvals and putting everything into production, ultimately via stages. This changed the effectiveness of developers a lot, because there was way less time that they had spent on actually building their software, and especially on distributing packages to ops. All this has been hidden behind that factory and automation wall, and that gave us the freedom to actually have joy and be productive during our development times. And we don't really have to care about putting software or something into production ultimately as a package. That was when containers and microservices got introduced. So containers and microservices are the logical consequences going all the way from a centralized waterfall-driven software development, project management, technological approach to the distributed cloud-based service-oriented world that we see today. This is mainly governed by DevOps methodologies. Individual application pieces are deployed via containers. They are written in individual services and no longer in bigger monolithic applications. So introducing microservices and containers left us almost speechless, with a completely wild world of all additional features and steps that you had to take. Gone were the days where we could simply build a zip file and put it on a thumb drive and just give that into production in some ways. We are now kind of required to not only test our software, but also test how it behaves and runs inside the deployment unit, which basically is a container. But not enough. The individual microservices also require more services, like all the interaction peers. They also require some kind of infrastructure components. Think about databases or security components, or think about messaging services. So all of this has to be there whenever you start testing. And instead of just having to deal with source code, now you start dealing with container images. And yes, we still have this continuous integration, continuous delivery approach. And yes, the artifact changed quite a bit. So instead of having a bit of source code that gets like built and packaged according to like one binary after all, we now have an image with versions and names. And these images also have to be organized in some kind of repositories. And just to suit all the security requirements and distribution aspects in larger clusters, these are kept in individual repositories. And these image registries, that's what they're called, they also need to be in this kind of setting. So we have a local kind of registry, which could be little more than a cache, a file system, but we also have a productive registry, which does a lot more, including security scanning. So yeah, long story short, looking at the actual developer productivity, that got decreased quite significantly again. There's still coding involved, which the name developer implies. There's still testing involved, but building still takes a lot of time, because these images are a little bigger. They basically not only contain your business application, they also contain everything you need to run your business application. Ideally, just a JVM plus operating system, but maybe even more. So depending on complexity, depending on the dependencies that you have with your images, it can take a while to actually build an image locally, run it, spin it up, test against it, kill it, and like start over again. And if you compare these numbers from the different approaches over time, And I totally agree that these percentages are completely made up. This is not in any kind of like artificial way, but it's more like a heartfelt way by an honest developer. We went from being 50% productive to the factory pattern, which let us be very, very, very effective as developers, to something that brings us down to just spending a little over 40% of our time, like as developers, developing software. And this is kind of a scary development, not only from a business perspective, because you just don't get that many features implemented that you wanted ultimately. There's also a lot of fun that is taken out of what I like to do best and most in my days, right? So I need to make sure that I, as a developer, get a chance to no longer look after infrastructure and the individual components. I don't care about Docker files, images, and stuff, right? And maybe it's not just me. I really want to make sure that we get our joy back as developers. So reducing non-developer tasks and optimizing the developer performance are kind of the key elements to developer joy and productivity. And to reach that, the first step is to actually radically reduce developer friction. You can reach that point by using Red Hat OpenShift. There's a very simple and opinionated way of using OpenShift as not only a container platform, but as a full-blown development platform. And there's also this like advanced driving, I'm an expert kind of mode. So depending on the scale where you see yourself, you can just use the exact right tools. And if you just want to code, if you want a simple and opinionated approach, you simply can just be productive as a developer and let OpenShift do the rest. And if you're still not convinced, there is a very nice report from IDC that literally tells everybody how much more than just a container platform OpenShift actually is. So make sure to download that. The second action that needs to be taken immediately is we need to bring back developer performance. What developers really want is a cohesive platform that they can just enjoy. So instead of taking that literally endless road all the way to production, we want to code, we want to reload our source code changes and see it in the browser like instantly. So we want to have that almost live coding experience, simple unified configuration for everything. Like don't want to mingle around and plumb the pipes. Everything underneath has to be already there. So everything we do needs to be absolutely streamlined and has meaningful defaults that we don't have to mess around with. Yes, add a little bit of command line modes and make this whole thingy, the platform, the framework, expandable to my personal needs. And this is definitely the thing I'm looking for. So perfect. And here comes Quarkus. This is the second piece of the equation. Quarkus basically gives you what came all the way from these J2EE servers into the more modern world with Java EE and our well-known monolithic approaches, and became microservices in a cloud-native world with microprofile. And using Quarkus gives you that developer joy platform with all the established and well-known coding patterns. So you can literally start developing with what you know as of today and safe and secure going all the way into the future with functional approaches, serverless programming, and event-driven applications. And here's the dream team. So the dream team between OpenShift and Quarkus brings you all the way from code to production, lets you monitor everything and even review changes. So you get the whole bunch in between, configuration management, log files and metrics for free because it comes all built in, which is a tremendous advantage. So that already was my time. I hope you enjoyed it. So thanks for listening today and thank you for being here. Have a cup of coffee on me.